Where did I put my marker?
I mean, there was one that I found over there on this desk.
No. The high tech marker.
Let's hope you didn't throw that away.
Have I seen my marker anywhere? Like not one of those, but like my fancy.
Under this.
No learning can take place without that marker. Somebody just stole mine. Thank you. Bonus points if you find my marker.
Steven stole it. Thanks, Steven.
Steven makes a comment.
Oh, I can't make any points. Get up. Wait, do I really get points for that?
No. Yeah, give you 1 point.
Okay.
Right.
1 point.
You know what I'll do? Just kind of forgot English.
I'll show you the pictures.
Alright, I'm gonna draw this again on the board just for the purposes of the video, because the video can't see that. And then you can fill in what we're gonna fill in based on I'm gonna write it on the board too, but I want to put it on here so if people are absent, or I know you guys go back and watch these.
Actually, yes.
Couple, 3 times a week. Couple, 3 times a day, right? Sorry.
I never watched one.
Yeah.
It's a couple 3.
Thanks, Nick.
A couple 3 times a day.
Alright. So, if you are within... So, mu is mean. Because the AP, the stats, AP doesn't use like Greek letters to represent these things. So mu, that's mu. Greek letter mu. It means mean. This is sigma, that means standard deviation. So what this means is if I go 1 standard deviation to the right, plus 2 is 2 standard deviations to the right, minus 1 is 1 standard deviation to the left, etc. The empirical rule is an estimate, but it's a pretty good estimate. If you are within 1 standard deviation either way from the mean, and the curve is absolutely perfectly normal, which is really rare. But if that were true, approximately 68% of the data is within 1 standard deviation. Alright, so if I go 2 standard deviations each way, that is 95% of the data. And if I go 3, can you guys even read that? That's like kind of legible.
Green?
Yeah.
Yeah.
That's 99.7%. Bless you. Yeah. She is. Whenever, or does it have to be now? Okay. Because they want you to go to the office. I said no, I don't know. You get in trouble?
You should have told me your dropping some knowledge. Right here.
That would be something to have on video.
Alright, so what we can do then is basically fill in all these little sections and put a percent in each one of those sections. So if there's 68% of the data within 1 standard deviation either way, couldn't I then look at this and say what percentage is in this part and what percentage is in this part? So those are both 34, right? See if you can fill the rest of them. And if you want to wait until I do it so you know you're right, you can do that too. But I don't think it's too bad. Try it. If you're not comfortable writing it down, just kind of put it in your head and wait. See if you got it. this one is 13.5. If it decides to write it.
Yes.
So let me just talk through how I got 13.5. It's technical difficulties here. Oh, it did. Okay. So like, what I'm trying to get you to process is if 95% of the data is in between there and there, and I know 68% of it is already like used up, so I got 95, but 68 of it's gone. What percent is left? 27, right? So these two have to add up to 27, and it's symmetric, so they got to be the same. So if you divide 27 by 2, you're going to get 13.5% in both of those. So try that with the next. See if you can apply that same thought process to the next two sections on either side. So if we're looking 3 each way, so plus 3 standard deviations, minus 3 standard deviations. So in that giant window, we got 99.7%. How much is already used up though? 95. So what's left is 4.7%, right? So if we cut that in half, that little section is 2.35%, and that little section is 2.35%. And then this little tiny guy over here, so the 99.7 covers up to 3 standard deviations, but we didn't get to 100% yet, right? This has to represent 100% of the data. We've only represented 99.7%, so what's left? 0.3%, right? And if we split that, that means this part over here is 0.15%, and this part over here is 0.15%. Yeah.
Is that then assuming that all data can be found with their source standard deviation mean? No. If it's a normal.
No, I wouldn't assume that because the 0.15 is basically like -3 and lower.
Okay.
So it could be a negative. Well, I mean, if we wanted to get really more specific, we could. I bet you between +4 and -4 is like 99.995, and then I mean you could like get really picky about it, but does that answer your question?
Yes.
All right, so I'm going to leave this on the board over here, and then I'm going to start like going through questions here. I just wanted to have that on the video. Yeah.
So that only occurs when it's symmetrical?
So, okay, let's write that up. This is the empirical rule. So it's estimates for a normal distribution. So normal distribution is like that, you know, the normal curve where you get that bell shape kind of thing. If it tells you, if we know that the data, if we know that the data is normal, we can use this. That's what you're saying, right? I should have said that. All right, so you get questions that look like this. So the average IQ score is 100. Standard deviation of 15. 100 is true. 100 is average. I don't know what the standard deviation is. I'm going to say find the percentage of people with IQ over 115. IQ between 70 and 100. IQ less than 70. IQ between 85 and 130. Stop doing that. let's just start with those. Yeah.
Now, wouldn't the question, like if it was on the AP test or whatever, though, to identify that it wanted us to like do this or use the Emperical Rule, wouldn't it say like assume that it is?
Yeah. So I should say like the average IQ score is normally distributed with a mean of 100 and a standard deviation of 15. So write those down, and then we'll go through how to use the normal curve thing to find it. What? Keep it down back there, will you? I think that was you this one. That was you. I don't care. Sorry. That's good. But if that was his sneeze, that would have been 20 seconds. Hello. I love you. Like to come in and learn some stats.
Wow, it's a rare occasion. You let someone come in.
I don't know, we're done.
Sit down.
What?
Sit down.
Yeah.
You just sit down. You just sit in class.
Destroy.
Bigger do the problems.
Have you done the problem? I'm not even. Yeah, I'm not saying you have to do it yet. I'm gonna go through it. You're welcome to start. I don't care. But Joel. So there'd be a couple things that ask you to do. One, they might ask you to just graph it or sketch a graph. If they ask you to sketch a graph, you're putting 100 there and saying, okay, that's the mean. Putting 85 there and saying that's minus 1 standard deviation. Putting 70 there and saying that's minus 2 standard deviations. 55 is minus 3. And they don't typically ask you to graph it, but I've seen it. And then if you really wanted to, you could like draw those dotted lines and just kind of put the percents in this specific problem and work it that way. It depends on what's easier for you, whether you want to draw it again every time or just look at this every time. Am I good to start explaining or are people still writing? Still writing? Alright. I'll wait 5 seconds. That's how patient I am.
So if it's from the middle, it's automatically. If it's from like the mean down or the mean up, it's automatically 50%, right?
Why?
Because it's normal.
What is it about normal that makes the mean right in the middle?
Because
Yeah. Because it's symmetric, you can do that. Yeah. Are you guys trying them or am I just waiting for you to write them? I don't care.
I'm done.
Good job. What were you asking?
Sort of.
Okay.
I didn't add the numbers together. So
Alright, so all you're looking at is you're just translating that information into this and going, okay, over 115. Well, 115 is 1 standard deviation above the mean. So I'm here, and I want to know over 115. So I'm taking this, and I'm just adding up everything that's above that. So 13.5 plus 2.35 plus 0.15. I believe that's 16%.
Yeah.
So you're just adding up those sections. And now be careful. The only thing that, and I'll put one up like this in a second, but sometimes they'll say what percent. Sometimes they'll say what's the probability, which is basically percent. That's almost the same thing. Sometimes they'll say how many. So like if I told you there were 1,000 people in this, and I asked how many people have an IQ over 115, then you'd have to take the 16% and multiply it by 1,000 people and figure out the amount of people. It's not like a hard step, but it's easy for you to do.
For A, could you in theory also take 50% and then minus the 34?
You could do a whole bunch of different things. Wait, 50%. Yes, okay, so she's saying,
Minus the 30.
I know that half are above there.
'Cause that's
I don't want this section. So 50 minus this section would lead me to those three sections, right?
It's just easier.
You could also add up all of these and do 100 minus. I don't know why you would, but does that make sense though? That like above this is just the opposite of below this? Like if this is 16% up here, what's down here?
Everything else
Which is?
is 84.
Right. You guys know what I'm saying or no?
Yeah, I get it.
What do you guys at?
He was wondering what the last one was on the right.
I keep between 70 and 100, so again, I'm just going over here and going, well, 70's 2 standard deviations below, 100's the middle. It's those two sections, I just add them up. So do C, D, and E if you haven't already. Okay.
Nothing. Nothing. There wasn't
It's like a Greek.
You just start squirting.
Okay, let's go. Top.
It'd be a perfect dealer because no one ever suspected. Yeah.
Yeah, that'd be so funny if you actually dealt drugs in real life.
Wink, wink.
Stephen, please don't call the police. We're
I'm kidding.
we're all kidding. I promise. Hopefully. Stitches, Stephen.
No.
Like some kid person who comments on all these videos for help, but they can't figure out where it is.
I think is he starting to comment on Instagram or your Stephen, what's your pronouns?
I'm Steven. My pronouns are them, there, them.
Like horror or just.
Are we good? Alright. So IQ less than 70, so I'm going 2 standard deviations below and just adding up those, so 2.5%. Between 85 and 130, so that's 1 below to 2 above, so 68 plus that 13.5, so 81.5. And then under 100, well 100 is right in the middle, right? Is 100 the mean? Yes, is 100 the median? Yes. Why? Why are those the same? There's no, there's no skew, right? So if there's skew, it pulls the mean one way or the other, but when it's symmetric like this, they're right in the same spot. Questions on this? How many out of those?
So we're
Alright? Yeah, that was the summer word, right? Let me put up one more. Ask just a couple different kind of questions. I don't know. Why do I ask more?
Wait. Yeah, that's true. There's no way that's not true. I know 2 people who read that book. Besides me. Do not ever turn on anything. I say it every day.
the first time in this
Video, so I can show through the.
So do these 3. It's up to you if you write it down. I don't. That doesn't matter to me. Just do them.
Ew.
Like the hard room, it's like on that side, and then the yearbook roof. I think it's usually hard to find. And it's like not like a sit down desk class. People just walk around.
Yeah, well, actually, yeah, probably.
Oh, really?
Yeah. Here's the kind of person that would be very like this.
Who is it?
I think it was kids.
Who?
Or no.
You don't know who it
The
is.
people that you would see in reality.
Any question or you just stretching it out?
Stretching it out.
Sorry to interrupt you.
I guess I'll list.
Well,
Maybe after we're done with those, we'll see class. Thank you for something like that. It looks just like your stretch. There's no difference. Wouldn't it be 2.5%?
Maybe Steven can't see it.
maybe see
2.5
through it.
because
No, maybe Steven is.
are we doing part C? 1250
Maybe
is
not,
two
because I
standard
know
deviation
and I know.
above.
Oh, okay. I know that Steven is not why.
So you're gonna have to like
No one on paper for comparing 4 or 5 times unless you're over here. Here doesn't take it in this class.
So this should give you.
So if that does happen.
Like 3 of us will be
No, just put you put like.
Okay, how are you, Stephen? You seem really confident knowing who it is.
Good to go?
Yeah.
Yeah, we're just trying to figure out who Stephen
All right.
is.
So what percent of students are below 950?
16.
Well, in this situation, the mean is 1050. So 950 is there, and if I add up those three down below, that is 16%. What percent are, so basically what percent are not
16.
between, they're basically saying what percent are not between here and here. So you can do that two ways. You could add up these two, which will give you the percent that are in between there and there, and then do what with that?
It's right under it. It's right under it.
I understand that 68. What would I do after I found the 68?
100 minus
Subtract that
68.
You'd have to do 100 minus that, right? Because I want like everything else. Or you could add up this, and get to the same thing. It depends what you think is faster. The last one is just trying to make sure you watch out for the how many instead of the what percent. So 1250 or higher, so 1050, 1150, 1250, we're up here. So it's 2.5%, but I didn't say what percent. I said how many. So you got to do 0.025 times the 200 students. Is that 5?
Yes.
All right, questions on that? Good enough? All right, on the packet I just gave you, the first couple pages are standard deviation, which we already did, so you can skip past those.
Thanks.
You can you can rip them out if you want. I don't care. I know.
It's fine. That's
And so starting here, I want this page and the next page. I want these two pages.
Where?
So 7 and 8.
I should have numbered them. I think every year after I print them, I'm like, damn it. why
Well,
did I
they do have like the numbers for the question.
Like where these graphs start showing up is where you want us to start.
1 through 7.
So it's 1 through 7 on that.
Okay.
Yeah.
So how much percent?
7 just happens to have like a bunch of parts.